Hello everyone. In this video, I am going to explain equilibrium and Le Chatelier's principle. Definition of the principle. This principle is named after French chemist Henri Louis Le Chatelier, known as Le Chatelier's principle, and this principle states that at equilibrium, if a reaction is subjected to change in parameters like temperature, inert gases, pressure, or concentration of reactants and products, the reaction equilibrium shifts in a direction in which the change is counteracted upon. That is, if any of the parameters is changed, the position of equilibrium also changes. The reaction either moves in the forward direction or in the backward direction so as to balance the imposed change on the equilibrium. Factors affecting the direction of equilibrium. Number 1, effect of concentration, effect of pressure and volume, effect of temperature, effect of catalyst. Let us first take effect of concentration into discussion. To discuss this, let us take one example. Example of formation of sulfur trioxide from sulfur dioxide and oxygen in the presence of catalyst. Now let us assume that the concentration of reactants increases. Now that is, the concentration of sulfur dioxide or oxygen is increased. So according to Le Chatelier's principle, the equilibrium will shift in such a way so as to counteract the increased concentration of reactants. And how the reactants concentration can be decreased? They can be decreased if they combine with one another to form the products. That is, if the reaction moves in the forward direction. If the concentration of products decreases, then the decreased concentration of products can be increased. And how it can be increased? It can be increased if the reaction is made to move in the forward direction. That is, more of sulfur dioxide and oxygen will combine to form sulfur trioxide. Now, third case, if the concentration of reactants decreases, so according to Le Chatelier's principle, the concentration of reactants must increase. Here, the imposed change is decrease in concentration of reactants. So, to balance that imposed change, the concentration of reactants must increase. And how it can be increased? If the concentration of products decreases, that is, if sulfur trioxide moves in the backward direction to produce sulfur dioxide and oxygen, that is, the equilibrium will shift in the backward direction. Effect of pressure and volume. Let us take the same example to understand the effect of pressure and volume. First case, when the pressure of system is increased. Increase in pressure means the volume of system has decreased. Then the number of moles per unit volume increase. So according to Le Chatelier's principle, the equilibrium will shift in such a way to cancel out the imposed change, to cancel out the increase in the pressure. That is, to cancel out the number of moles per unit volume which are increased. That is, the reaction will move in such a way to decrease the number of moles. You can see here on the reactant side number of moles are 3, but on the product side number of moles are 2. It means the reaction will move in the forward direction. That is, the reaction will move towards the lesser number of moles on increasing the pressure. Similarly, when pressure of system is decreased, it means number of moles per unit volume decreases. The equilibrium will shift in such a way to counteract the effect of decrease in number of moles. That is, the number of moles must increase. And how the number of moles can be increased? If the reaction goes in the backward direction. That is, the formation of reactants will be favored. Effect of volume is just the reverse of the effect of pressure, because pressure is inversely proportional to volume. Effect of catalyst. Catalyst is a chemical which increase or decrease the rate of reaction without undergoing any change in its composition. So, catalyst can not only increase the rate of forward reaction but also increase the backward reaction. So the ratio of concentration of products to the ratio of concentration of reactants will remain same. Hence, there will be no effect on equilibrium concentrations if a catalyst is used. Effect of temperature on equilibrium. Let us take the same example with enthalpy change for the reaction. Let us assume that enthalpy change for reaction is positive. Positive means the forward reaction is endothermic, backward reaction is exothermic. Case 1. When temperature is increased, the equilibrium will shift to decrease the increased temperature. And how the temperature can be decreased? If the increased temperature can be utilized during the course of reaction. That is, the reaction will move towards the endothermic direction. That is, the reaction will move in the forward direction. Case 2, when the temperature is decreased. Temperature is decreased means equilibrium will shift such as to increase the temperature. And how the temperature can be increased? The temperature can be increased if the reaction goes in the exothermic direction, and the backward reaction is exothermic reaction. That is, the reaction will move in the backward direction. There are some problems on Chatellier's principle. To understand this principle clearly, predict the conditions of concentration, pressure, temperature to get maximum yield of ammonia. That is, we want to make more and more amount of products. How they can be prepared? How can they can be synthesized? Number one, concentration. Concentration of reactants, that is nitrogen, hydrogen, should be increased so that the reaction can move in the forward direction. Second, pressure. See, the number of moles on product side are 2, number of moles on reactant side are 4. We have to move the reaction towards lesser number of moles, that is, pressure should be increased. Pressure is increased, number of moles increases, that is, the reaction will move towards the lesser number of moles, that is, more amount of ammonia will be formed. Effect of temperature. You can see forward reaction is exothermic reaction, backward reaction is endothermic reaction. So we have to move the reaction towards exothermic direction. That is, we have to decrease the temperature so that the reaction can move towards the increased temperature, that is in the forward direction. Second question, for this reaction which is exothermic, what happens if temperature is decreased? If temperature is decreased, the reaction will move in such a way to increase the temperature. And how the temperature can be increased? That is, the reaction will move in the forward direction. Thanks for watching.